Okay, so today we're going to talk about the ideal gas law. And so that is on your gas law reference chart, but I also have it here on your assignment. It is called PIVNERT, if you want to pronounce it, but it's pressure times volume equals number of moles times R, which is a constant, that's over here, times the temperature. And the temperature, of course, has to be in Kelvin. If you look here at R, this is a number that never changes, so it's 0.0821, and then the unit is really weird. It's liters times atmospheres divided by moles times Kelvin. The reason why it has this crazy unit is just so things cancel. But because of this unit, that means your pressure has to be in atmospheres, your volume has to be in liters, and your temperature has to be in Kelvin. So if you're given anything else, you're not going to be able to use whatever that is. So your pressure must be in atmospheres, your volume must be in liters, and your temperature must be in Kelvin. All right, so let's look at example 1. We're going to start with a list. So it says, how many moles of gas is 103 liters of SO2 at STP? So STP stands for standard temperature and pressure, all right? And that's going to be 0 degrees Celsius and 1 atmosphere. So this is actually a temperature and a pressure. It doesn't look like it, but it is, okay? And that is also on your gas law reference chart. So make sure you have that handy because all of that information is there for you. So I'm going to start with a list, P, V, N, R, and T. All right, so it says 103 liters, that is a volume. My N is moles, that is unknown. My R never changes. It is always 0.0821 liter atmospheres divided by mole times Kelvin. Yes, you do have to write that unit, and yes, it is annoying, sorry. And then your temperature, it looks like we don't have enough information, but remember STP means 0 degrees Celsius, so that's my temperature, and then it means 1 atmosphere. Now, I have a problem with my Celsius temperature. I have to add 273 to make it be Kelvin, so that's going to be 273 Kelvin because we were at 0 degrees, okay? So you remember your temperature has to be in Kelvin, your pressure has to be in atmospheres, and your volume must be in liters, all right? So I'm going to plug in kind of, our law is PV equals N times R times T. So I'm going to plug in the things that I know. 1 atmosphere times my volume, 103 liters, equals N, which we don't know, times R. Now I'm going to leave off that first 0, but I have to include that second one after the decimal. It's 0.0821 liter atmospheres over mole times Kelvin, and then times my temperature of 273 degrees Kelvin. So that's just me plugging in PV equals nRT. So I'm going to solve here for N. Remember, parentheses next to each other mean multiply. So N is being multiplied by these two numbers. So we're going to divide by them one at a time. So first, I'm going to divide by 0.0821 liter atmospheres divided by mole Kelvin. And that's going to cancel on this side, but I have to do it over here. So I'm going to divide by 0.0821 liter atmospheres divided by mole times Kelvin. That's what that dot means, is times. And then we're also still need to get rid of this 273. It's also being multiplied by the N. So we're going to divide by 273 Kelvin. It's going to cancel over there, but we have to do it over here. So divide by 273 Kelvin. All right, so let's look at some units. So here I have atmospheres on top and atmospheres on bottom. I have liters on top and liters on bottom. I have Kelvin on top and Kelvin on bottom because of this fraction bar in my R unit. All right, so Kelvin's on top and Kelvin's on bottom. Even though they're both under the fraction, there's a little fraction here, and so it's top and bottom again. And I'm left with moles, which is a unit for N. Okay, so to solve, I'm gonna grab a different color here. To solve, you're going to be multiplying the top and dividing both of the numbers on the bottom. So that is going to be 1 times 103 divided by 0.0821 divided by 273. All right, so I get 4.595485716. And sig fig wise, now it did not give us the 1 atmospheres. It also didn't give us the 0. That's just STP. So the only given we have right here is 103. So everything else is kind of a constant or an implied thing. So 103 has 3 sig figs, so I'm going to round this to 3. So the 5 makes the 9 go up. So this is going to be N equals 4.60 moles. Okay, let's try another one. So this is going to be a little bit different. You're going to want a periodic table handy because we're given grams, and so we're going to have to get that to moles. What is the pressure exerted by 85.5 grams of CO2 at 27 degrees Celsius if the gas is contained in a 15.0 liter container? So we're going to do P, V, N, R, and T. So my pressure, it says what is the pressure? It's unknown. And then it says 27 degrees Celsius. That's my temperature. I cannot leave it as Celsius, so I'm going to go ahead and add 273. So 27 plus 273 equals 300 Kelvin. It tells me in a 15.0 liter container, that's a volume. My N, I don't know yet, but I could. Okay, so I'm going to show you how that works in just a second. My R is always this number, 0.0821 liter atmospheres divided by mole times Kelvin. All right, so your N, it's supposed to be moles. Well, we weren't given moles, we were given grams. So we're going to start with our grams, 85.5 grams. Then it tells me it's CO2. So I'm going to start that. All right, so I can take my grams and get to moles by doing a one-step train track. If this is grams of CO2, then down here has to be grams of CO2. Then I'm going to go to moles of CO2, and that's all I need, just one step. So mole is always going to get a 1, and then grams is going to come from the periodic table. So we're going to add together the mass of C plus 2 times the mass of O. So carbon's mass is 12.011. So 12.011 plus, and then oxygen is 15.999, and there's 2 of them in my formula. So plus 2 times 15.999. So that's 44.009 grams per mole. So just like before, you're going to multiply the top and divide the bottom. So 85.5 divided by, times 1 divided by 44.009. So this is what I got. And we're going to go ahead and round that to the sig figs that started my train track. So I'm going to round that to 3. So it's going to be 1.94 moles of CO2. Change that to black so you can see it better. Okay, now it's like extra dark. All right, so now we have everything except for pressure, so now I can go ahead and solve. So I have P, which I don't know, times my volume, because remember my formula is PV equals N times R times T. All right, V is 15.0 liters equals my N I just solved for with my train track. So anytime you're given grams, you can get it to moles. So that's going to be 1.94 moles times my R, which is 0.0821 liter atmospheres divided by mole times Kelvin. And then we're going to multiply that by our temperature in Kelvin, which is 300 Kelvin. Let's get this over so y'all can see that. So PV equals nRT. So now we're solving for P. So you're going to like when you're solving for P or V because you're only going to have to just get rid of one number instead of having to write R a million times. So right now, P is being multiplied by 15.0. So to undo that, I'm going to divide by 15.0 liters. That's going to cancel. But over here, I have to do the same thing. So divided by 15.0 liters. That's all I have to do to get rid of it to solve for P. So unit-wise, let's see what cancels. I have moles on top and moles on bottom. Remember, R has a fraction in it, so it's going to make things cancel. All right, I have Kelvin on top here and Kelvin on bottom underneath a little fraction. I have liters on top and liters on bottom of the big fraction bar, and I'm left with atmospheres, which is my unit for pressure. Pressure has to be in atmospheres in order to use the Pivnert formula, the ideal gas law. Okay, so to solve, you're going to be multiplying the top 3 numbers and dividing by the one number on the bottom. So 1.94 times 0.0821 times 300 divided by 15.0. Okay, so another thing, I know some of you are watching and you're like, Miss, you didn't use the right number of zeros. Like I said, you don't have to write this very first zero, but you do have to write 0.0821. So either one of those is acceptable to me. Sometimes I write it, sometimes I don't. It just depends. Okay, I'm not gonna count off points for you, but it must be 0.0821, not 0.821. Okay, must be 0.0821. So this is what I got, and we're gonna round to sig figs. So I was given 3 here in the problem. That's 2, and that's 3. The smallest number I was actually given is 2. So I'm gonna round this to 2. So 3.18, the 8 makes the 1 go up. So this is going to be P equals 3.2. The unit for pressure that didn't cancel is atmospheres. Okay, I'm gonna try one more. What is the mass of 7.1 liters of nitrogen at 26 degrees and 18.5 psi? So we have a lot of stuff going on in this one. So I'm going to start with my list. P, V, N, R, T. All right, so my pressure is 18.5 psi. My volume is 7.1 liters. My N is unknown. My temperature is 26 degrees Celsius. I'm gonna go ahead and add 273 because I can't, so it's gonna be 299 Kelvin. My R is always 0.0821 liter atmospheres divided by mole times Kelvin. All right, so couple things. We can't have pressure in PSI. To use the ideal gas law, you have to have pressure in atmospheres. Notice STP is in atmospheres, okay? So I'm gonna go ahead and one step convert this. This is gonna be PSI on the bottom. This is gonna be atmospheres on top. If you look at your gas law reference chart, you have all of these standard numbers here. Standard for PSI is 14.7. Standard for atmospheres is just 1. So you're gonna multiply the top, divide the bottom. We're gonna round to 3 sig figs because that's what I started with. So 18.5 times 1 divided by 14.7. Okay, so 18.5 times 1 divided by 14.7 gives me 1.26. The 8 makes the 5 go up. So this is 1.26 atmospheres. That's gonna be the pressure that I'm gonna use. Okay. So when we solve this, we're going to get moles, but my question says, what is the mass? So we're gonna get moles, but we're gonna change it into grams in just a minute, okay? So I'm gonna go ahead and plug in what I know. So I know it's PV equals N times R times T. So my pressure is 1.26 atmospheres. My volume is 7.1 liters equals my N, which I don't know. My R is 0.0821 liter atmospheres divided by mole times Kelvin. My T is 299 Kelvin. All right, so we gotta solve for N. So unfortunately, we are gonna have to be dividing by R. So I'm gonna change colors here. So first I'm gonna go ahead and divide by 0.0821 liter atmospheres divided by mole times Kelvin. That's gonna cancel, but I gotta do it over here. 0.0821 liter atmospheres divided by mole Kelvin. And then I'm still over here, N is still being multiplied by 299. So I'm gonna divide by 299 Kelvin. It's gonna cancel over there. Over here, I have to divide by 299 Kelvin. So let's look at units. Atmospheres on top, atmospheres on bottom. Liters on top, liters on bottom. Kelvin on top, Kelvin on bottom of the little fraction for R, left with moles, which is what I want in order to get to mass. So to solve for moles first, I'm gonna multiply the 2 top numbers, divide the 2 bottom numbers. So I'm gonna do that now. So 1.26 times 7.1 divided by 0.0821 divided by 299. All right, so everything is 2 sig figs, it looks like. So I'm gonna go ahead and round to 2 sig figs. So this is what I got in my calculator. So I'm gonna round that to 0.36. The 4 makes the 6 stay. So 0.36 moles. And we know it's nitrogen, Okay, so nitrogen is N. Okay, but N is one of those diatomics. It's one of those elements that doesn't like to be alone. So it's actually going to be N2. Oxygen, nitrogen, hydrogen, all of those are going to be just like that. Okay, so you're going to have to know that. All right, so I'm going to do a one-step problem. This is moles. I'm trying to get to mass, which is grams. So I'm going to have moles down here of N2, and then I'm going to have grams of N2 on the top. Nothing goes here. One goes with mole. That is going to come from the periodic table. So the mass of one nitrogen is 14.007, but there's two of them. So I'm going to do 14.007 times 2. And that's going to be my mass of N2. So 28.014. So now to solve, we have moles canceling. We're going to multiply the top and divide the bottom. So 0.36 times 28.014 divided by 1. So this is going to be in grams of N2, and we're going to go ahead and round this to 2 sig figs because that's kind of what I started, and that's the least number I was given here. So this is going to be 10 with a decimal because the 0 does nothing, and then grams N2. All right. So these are a little bit more difficult. This is definitely a pre-AP assignment. Please email me if you have questions.